Touchdown confirmed. Perseverance has safely landed on the surface of Mars, ready to begin its search for signs of past life. But while one rover scours the surface, another mission has been silently working deep beneath Mars, uncovering secrets that could rewrite everything we thought we knew about the red planet. Show NASA's InSight lander deploying instruments for decades, scientists have questioned what lies beneath Mars' barren surface. Now, thanks to seismic data from NASA's InSight lander, we have finally peered into the core of the red planet, and what we found is beyond anything we expected. Quick montage of Mars visuals. Planetary core animations. Mars' heart isn't just a lifeless chunk of rock. It's moving, shifting, and behaving in ways that no one thought possible. But here's where it gets even more mind-blowing. The very thing that makes Mars' core unique might also explain why the planet lost its atmosphere, its magnetic field, and ultimately, its ability to support life. Show animation of Mars losing its atmosphere over time. So what did NASA really find deep beneath the Martian surface? And could this shocking discovery tell us something crucial about Earth's own future? Let's dive in. Title card: Shocking Discovery. Mars' core is not what scientists expected. For years, planetary scientists believed Mars had a core structure similar to Earth's, a solid inner core made of iron and nickel, surrounded by a molten outer layer. This assumption made sense. After all, both Earth and Mars formed from the same primordial material in the early solar system. If Earth had a solid core, why wouldn't Mars? Show Earth's internal structure. Comparing it to a hypothesized Mars core, scientists theorized that Mars once had a functioning magnetic field, a thick atmosphere, and conditions capable of sustaining liquid water. The theory suggested that over time, the core cooled, the magnetic field weakened, and the planet's atmosphere was stripped away by the relentless solar wind. Show animation of Mars losing its magnetic field and atmosphere, but this assumption was wrong. And NASA's InSight lander just proved it. In 2018, NASA's InSight lander touched down on the Martian surface, equipped with highly sensitive instruments to detect seismic activity. Its mission? To listen for Marsquakes and use their seismic waves to map the planet's interior. Just like earthquakes on Earth allow scientists to study our planet's layers, Marsquakes offered a unique window into the hidden depths of the red planet. Show InSight lander deploying its seismometer. Says as InSight gathered data, scientists noticed something strange. If Mars had a solid inner core, seismic waves should have bounced off it in predictable ways. But they didn't. Instead, they passed straight through Mars' center without interruption. Show seismic wave simulations passing through Mars. This was a game changer. Unlike Earth, which has both a solid inner core and a liquid outer core, Mars' entire core is molten, containing a mixture of iron, sulfur, oxygen, and other light elements. And this changes everything. Without a solid inner core, Mars never had a stable magnetic field for long. And without that magnetic shield, the solar wind stripped away its atmosphere, turning what may have once been a thriving world into the frozen desert we see today. Show an artistic recreation of early Mars with water and a thicker atmosphere, transitioning to modern barren Mars. This discovery forces us to rethink not just Mars' past, but its entire geological history. If Mars' core never solidified, what does that mean for its ancient climate? Could it have ever supported life? And most intriguingly, if Mars' fate was sealed by its molten core, could Earth suffer a similar destiny billions of years from now? Show footage of InSight's RISE experiment, tracking Mars wobble. To double-check these seismic findings, scientists turned to another method, tracking Mars' tiny wobbles as it orbits the Sun. Just like how a raw egg wobbles differently from a boiled egg, a planet's rotation changes depending on its internal structure. If Mars had a solid inner core, it would have rotated differently. But the data confirmed it. Mars' core is fully liquid, with no solid center to stabilize its spin. Show data visualization of Mars' wobble and rotation patterns. But why did Mars' core stay molten while Earth solidified? The answer lies in three critical factors: composition, size, and cooling rate. Mars' core contains a much higher percentage of light elements like sulfur, oxygen, carbon, and hydrogen compared to Earth's. These elements lower the density of the core, making it more difficult for iron and nickel to crystallize into a solid structure. In fact, nearly 20% of Mars' core is made up of these lighter elements, whereas Earth's core has only a fraction. Size plays a crucial role in planetary evolution. Earth's enormous mass creates extreme pressures that force its inner core to solidify despite its scorching temperatures. Mars, being only 1/10 the mass of Earth, never reached those pressures. This meant that even though its core contained iron, it never solidified like Earth's. Mars lost heat much more quickly than Earth due to its small size and lack of plate tectonics. Without volcanic activity to recycle heat, the planet cooled rapidly, leading to the early loss of its magnetic field and atmosphere. Earth, on the other hand, retains heat thanks to its larger size, active plate tectonics, and solid inner core sustaining its magnetic field. Mars' fate was sealed by its molten core. Could Earth suffer a similar destiny? Our planet's solid inner core is growing at a rate of about 1 mm per year. Scientists estimate that in a few billion years, Earth's core may fully solidify, shutting down our magnetic field and exposing our planet to the solar wind, just like what happened to Mars. Show an animation of Earth gradually losing its magnetic field and atmosphere over billions of years. The good news? We have billions of years to prepare. But studying Mars is crucial, not just to understand its past, but to prepare for Earth's future. NASA's InSight mission has fundamentally changed our understanding of Mars. But there's still more to discover. What other secrets does the red planet hold beneath its surface? And could they unlock answers about our own place in the universe? Stay tuned as we continue to unravel the mysteries of Mars. Don't forget to like, subscribe, and turn on notifications so you never miss a discovery. Please like, share, subscribe and comment. Thank you for watching my channel.